You think you're touching something right now. Your phone, your chair, the floor beneath your feet. It feels obvious, undeniable. After all, you can feel it. But here's the uncomfortable truth. You have never touched anything, not once, not ever. Not a table, not a wall, not even another human being. In fact, you will never touch a single atom for as long as the universe exists. That sounds arrogant, provocative, maybe even ridiculous. And yet, the laws of physics don't just suggest this, they demand it. So today, I want to take you on a journey from your fingertips down through atoms into empty space, electric forces, probability clouds, and finally into a philosophical realization that Richard Feynman loved more than almost anything. Reality is not what it feels like, and that's what makes it beautiful. Let me ask you something. When you press your hand against a table, what do you feel? Resistance, firmness, solidity. Your brain concludes, I am touching the table. Reasonable, logical, evolutionarily useful, but physics doesn't care about what feels reasonable. Physics asks a colder question. What is actually happening at the smallest level? To answer that, we need to zoom in, way in. Your hand is made of atoms. The table is made of atoms, so you might imagine tiny, solid balls, like microscopic marbles, pressing against each other. But that picture is already wrong, because atoms are not solid. They are almost entirely empty space. If an atom were the size of a football stadium, the nucleus would be a grain of sand at the center. Everything else, nothing, void, probability. So when your hand approaches the table, something strange happens. The atoms in your hand never actually collide with the atoms in the table. They can't. Every atom is surrounded by electrons, tiny, negatively charged particles. And here's one of the most rigid laws in all of nature, like charges repel. When the electrons in your hand get close to the electrons in the table, they push each other away, hard. What you feel as touch is not contact. It's electromagnetic repulsion. A force, a push. A silent, invisible refusal of nature to let atoms overlap. Richard Feynman loved this idea because it flips reality upside down. You're not feeling matter, you're feeling fields. Imagine two powerful magnets. They never actually touch. But you feel resistance as you push them together. That invisible pressure, that's what your entire physical world is made of. Your chair isn't solid. Your walls aren't solid. You aren't solid. You are walking through a universe of force fields pretending to be objects. And the illusion works so well that we forget it's an illusion at all. But wait, why don't we fall through everything? Visual, person standing on the ground, atoms highlighted beneath feet. At this point, you might ask, if atoms are mostly empty space, why don't I fall straight through the floor? Excellent question. The answer is statistics and pressure and enormous numbers at the microscopic level. Atoms behave probabilistically. Electrons don't have exact positions. They exist as clouds of probability. But at the macroscopic level, where trillions upon trillions of atoms act together, those probabilities average out into something stable. It's the same reason. A single water molecule is unpredictable, but an ocean behaves reliably. The laws don't change. The scale does. Have you ever seen someone lie on a bed of nails? One nail would pierce the skin. 1,000 nails, perfectly safe. Why? Because force gets distributed. The solidity of the floor beneath you isn't one atom pushing back. It's an astronomical conspiracy of electrons, all repelling at once. You're not standing on the floor. You're hovering for ever so slightly above it. There's another rule, deeper, stranger, and even more unforgiving, the Pauli Exclusion Principle. It says, no two electrons can occupy the same quantum state at the same time. This is not a preference. It's not a suggestion. It's a law so absolute that if it failed, matter itself would collapse. So when you try to touch an atom, the universe responds, no, not violently, not dramatically, just firmly. Imagine a theater where every seat is occupied. You walk in and ask politely if you can sit. Physics doesn't argue. Physics doesn't negotiate. Physics just says, there is no room. That's what electrons are doing every moment of your life. But wait, you might say, what about cutting something, or pain, or breaking bones? Surely that is contact. Nope. Still forces. A knife doesn't touch atoms either. It applies enormous localized electromagnetic forces, overwhelming molecular bonds. Pain is not contact. Pain is your nervous system screaming. The forces here are too strong. Biology doesn't escape physics. It obeys it. This is where Feynman would lean back, smile, and say something like, "So what are you really? You are not a solid object moving through a solid world. You are a temporary pattern of energy, stabilized by forces, dancing on the edge of chaos. You don't touch the universe, you interact with it, and interaction is far more interesting than contact." At first, this idea can feel unsettling. If nothing truly touches, is everything fake? No, it's the opposite. It means existence is delicate. Every hug, every handshake, every kiss is a precise orchestration of forces that almost allow closeness, but never collapse into sameness. You and the universe meet at the edge of impossibility. That boundary, where touch fails, is where structure survives. The universe trends toward disorder, always. And yet, against that tide, atoms organize into stars, cells, thoughts, and questions like this one. You are not a violation of physics. You are what physics does when conditions allow complexity to bloom. Briefly, touch would destroy structure. Distance preserves it. Feynman didn't find this depressing. He found it exhilarating because it means the universe doesn't need solidity to feel real. Reality is relationships, forces, interactions, constraints. You are not separate from the universe. You are how the universe feels from the inside. So here's the final twist. You will never touch a single atom, and yet you felt love, warmth, connection, pain, meaning, all without contact. So let me ask you, if the universe can feel this real without anything ever truly touching, what else might you be misunderstanding about reality? Tell me what this idea changed for you. I'll be reading, because the laws of physics say no, but wonder says yes.